there, fourth graders. Today we're going to be doing a lesson on comparing and ordering decimals. And before we get started, I want to remind you of two things. First of all, unlike a real live classroom, you can pause this lesson at any time if you need extra time to fill something out or think about it, or if you need to take a break from the lesson. So that's a nice bonus of learning at home with a screen. Secondly, it is important that you listen all the way through this lesson. At the end, I'm going to give you some important information about your assignments today. And third, today's notes are going to start off, or today's lesson will start off by using a little section of your notes that are currently blank. So if you go back and look in your math notebook, we did do the top of this page of notes about thousands, but there's still a little section at the bottom about equivalent decimals that's blank. So if you've got that handy, please use it and follow along. If you don't, that's okay though. You can still follow along and listen and watch. So before we start comparing decimals, let's first understand how to find equivalent decimals. Just like fractions, decimals can be equivalent to each other. Remember that word equivalent just means that they name an equal amount using different numbers. So let's start off with the decimal 1/10, one shaded out of 10 pieces. If we move over here to the hundreds, how many hundreds would we need to shade to be equivalent to that 1/10? Well, if you think about it, one of these columns in the hundreds is equal to 10, and that's equal to one of those tens. So in other words, 10 hundredths is equal to 1/10. They name the same amount. Moving over to the thousands, you can see we would need to shade one of those columns going down to be equal, and that would actually be 100 thousandths. So if you kind of look at the little blocks, a block that looks like this has 10 in it, and I would need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to equal the same amount. So it's actually 100 thousandths. Let's try a different one. Let's take a look at 3/10. How many hundredths would I need to shade to be equal to 3/10? Well, since each one of these columns of 10 is the same thing as one of these tenths, it's going to take 3 of those columns, or 10, 20, 30 hundredths, to be equal to 3/10. And finally, look at our thousandths. Remember that one of these columns is 100, so it's going to take 3 of those columns, so 100, 200, 300 thousandths is equal to 3/10. Now let's take a look at the decimal numbers that we just came up with and see if you notice a pattern in what we're doing to actually make equivalent decimals. Finding equivalent decimals is actually a lot easier than finding equivalent fractions because all we're actually doing here is just adding zeros to the end of the decimal, and that makes each decimal equal to each other. So super important idea here. To make an equivalent decimal, all we have to do is just add, or we even could take away zeros from the end of the decimal. That's it. That's all you have to do. The fine print here is that this only works with decimals. We can take 65 hundredths, add a 0 to the end, and make 650 thousandths, and those will be equal to each other. It does not work if we're dealing with whole numbers. 65 is not the same as 650. So again, all we have to do is stick zeros at the end, and that gives us decimals that are equivalent or equal to each other. Let's see if you can find some equivalent decimals. I'll get you started here. Circle 6/10, and then look in that box and see if you can find 2 other decimals that are equivalent to 6/10. You should have circled 60 hundredths and 600 thousandths because those have the 6/10 with zeros stuck at the end. Try this box and see if you can find 3 equivalent decimals. You should have circled 900 thousandths, 90 hundredths, and 9/10, because again, all of those just have a 0 added or taken away from them. So let's practice that. Take a look at these pairs and let's decide if they're equivalent or not. Here we have 5/10. If you add 2 zeros to the end of it, you get 500,000. So those are equal to each other. 5/10 compared to 50/100. Again, I just added a 0 to the end. They both have a 5 in the tens place, so they're equal. This third example has a 5 in the tens place here, but there's a 0 in the tens place here. So instead of adding the 0 to the end of the number, it was added before it. That means they are not equal to each other. And the same thing on this last one here, adding 2 zeros before does not make them equal. We have to have basically the same number in the same place value and then add zeros to the end for them to be equal. So now let's try comparing some decimals. We'll start with ones that have the same number of digits. Or another way to think about that is decimals that, if we turn them into fractions, they're really ones that have the same denominator. So 5/10 means that it's divided into 10 pieces, and I have 5. 3/10 means we have a whole that's divided into 10 pieces, and we have 3. And it's really easy looking at those pictures, or the fractions, or the decimals, to figure out that 5/10 is greater. Let's try one with hundreds. Here we have 22 hundredths compared to 31 hundredths. And again, we can think about them as fractions, if that's an easier way for you to see it, or we can think about them as the pictures. But no matter how you look at it, 22 is going to be less than 31. Now let's take a look at what happens when we have mixed numbers out in front. So in this case, this is one whole pizza and 22 hundredths of another. This is 2 and 9 hundredths. So with one whole and 22 hundredths, when we compare that to 2 wholes and 9 hundredths, it's really the whole numbers that we need to look at first. It really doesn't matter how much pizza is left over in that box. If this one has 2 whole pizzas, it automatically is larger. So it should be 1 and 22 hundredths is less than 2 and 9 hundredths. Again, we're going to look at the whole number part first, and then it's only if those whole numbers would be the same that we'd have to look at the fraction part. It really doesn't matter that this is a bigger fraction because it doesn't have an extra whole pizza like this one. Now let's try some where we have a different number of digits. Now I'm comparing 4/10 to 9 hundredths. And this is a little harder to think about because this is divided into 10 pieces and this is divided into 100. So we're going to use our 0 trick here. We just said that you can add zeros to the end of a number and it doesn't change what that decimal is actually worth. So we're going to take these and add zeros to make a common denominator. So this one's out of tenths, this one's out of hundreds. So if I add a 0 to the end of this 4, now I have 40 hundredths. And now it's a lot easier to compare 40 hundredths to 9 hundredths. So if we look at the picture here, you're going to see that 40 hundredths, 4/10, is definitely greater than 9 hundredths. Let's try another example. We're comparing 7/10 to 459 thousandths. Now, a lot of students would think, just looking at those two, that the number that has more digits is automatically bigger, but that's really not true. Don't get tricked by that. Just because something has more digits doesn't mean that it's larger. It all has to do with place value. So since these have different denominators, they have a different number of digits after the place value, we're going to use our 0 trick. Add zeros to make them have a common denominator. So this one has 3 digits, this one only has 1. So I'm going to need to add 2 more zeros to the end of the tenths so that now I'm comparing and both of them are in the thousandths. So now I'm comparing 700 thousandths to 459 thousandths. And if you take a look at that picture or you think about those numbers, 700 is definitely bigger than 459 thousandths. Let's look at another example. We have 9 thousandths compared to 4 hundredths. And again, place value makes a big difference here. So 9 is more than 4, but we have to think about place values. So we're going to do our zeros trick. This one has 3 digits after the decimal. So we'll have to add an extra 0 over here so that now they have the same number of digits. And now we're comparing 40 thousandths to 9 thousandths. When you compare those, remember that we said thousands are like crumbs of pizza and hundreds are bites of pizza. So 9 crumbs of pizza is going to be less than 4 bites of pizza. We can also have, let me go back a sec. There we go. Let's try 4 tenths compared to 62 thousandths. Again, we have different denominators. So we're going to use our zeros trick. And we need to make sure that they have the same number of digits. So since there's 3 digits here, I'm going to have to add 2 more zeros over here so that it will also have 3 digits. That makes me comparing 400 thousandths to 62 thousandths. And when I compare those, that 400 thousandths or 4 tenths, that's 4 whole slices of pizza. That's definitely bigger than 62 crumbs. Now let's consider one that has mixed numbers. We have 2 wholes with 62 thousandths compared to 1 and 9 tenths. Now, in this case, before we even start adding zeros to the end, remember we talked about looking at the whole numbers first. And if you do that, you can actually figure this out without having to do the zeros trick. 2 whole pizzas is automatically bigger than 1 whole pizza. It really doesn't matter how much is left over. You certainly can still do the zero trick though. If I add the zeros to the end of this, now I've got 1 in 900 thousandths, but it's still going to be the 2 wholes over here that are going to be greater. Let's practice a couple of these where we're not looking at the pictures and we're just looking at the decimals. This is what your worksheets today will do. So the first thing I want to do when I'm comparing is look at whole numbers. There isn't any to compare here. And then I'll look to see whether or not they have the same number of digits. This is 21 compared to 3. And since they both have the same number of digits after the decimal, I don't have to do the zeros trick. I just compare. And 21 is, oops, I have my sign backwards on that. 21 is supposed to be greater than 3 hundredths. Sorry about that. Whoops, that's wrong. Let's take a look at 3 tenths compared to 13 hundredths. So in this case, I will have to add a 0 to the end of 30 since we have a different number of digits. So now I'm comparing 30 to 13 hundredths, and 30 is greater than 13. Here we have 5 hundredths compared to 9 thousandths. So 2 digits after the decimal here, 3 digits after the decimal here. We'll have to add a 0 to the end of this number, so they have the same number of digits. Now I'm comparing 50 to 9, and 50 is greater. And then the last problem here has got some whole numbers out in front. So let's make sure we check those first before we do anything else. And in this case, we have 1 is smaller than 2. So it really doesn't matter what the decimal is after that. It's automatically the 2 that's going to be larger. If we have 3 or more decimals to order, we're going to use the same strategy. We're going to add zeros to the end until we have them all using the same number of digits. So taking a look at these, this one has the most digits after the decimal. So I'm going to have to change the other 2 so that they match. So over here, I would have to add 1 digit so that there's 3 digits total. And over here, I'm going to have to add 2 digits so there's 3 digits total. So now I'm comparing 110, 43, and 300. So as I put these in order, 43 is the smallest. And then next, it would be 110. And I'm going to rewrite it. I'll take that 0 off and just leave it as 11 hundredths as it started with. And then finally, 300 thousandths, or 3 tenths, is the largest. Your assignments for today first are a quick worksheet that will practice this skill. So try this one out by adding zeros as you need to. Make sure you look at the whole numbers first. You're going to circle the one that's bigger. And I do just want to mention that not every problem that you circle up here will you find down here. So if you circle a letter but you can't find it down here, it doesn't automatically mean that it's wrong. After you've done that one, that's a quick practice, and your parents do have the answer key to it, so they can check it for you and make sure that you're understanding it. The second assignment today is a series of riddles, and you got the recording sheet, which is printed in your packet. Your parents were sent the actual questions as attachments. If we were doing this in class, these would be task cards that would be posted around the room that you would just go to. But since you're doing it at home, you can simply look at these on a screen. You don't have to necessarily print all 9 pages of it. If you really want the authentic classroom Mrs. Davis experience, your parents can print them and put them around the room, but you don't have to do that. Since this is a set of task cards that uses riddles, it's not something that's going to be graded. Instead, it's just a practice of this concept. And also, if we were doing this in class, remember with task cards, I give you a set amount of time to do them, and you just complete as many problems as you can in that time. So I'm going to ask for you to have your parents set a timer for 30 to 40 minutes for you to work on this assignment. And then if you don't finish it, that's okay. Some of these questions are a little more challenging, and this is not a graded assignment. It's good practice. There's some really good thinking questions in here, but it's not a graded assignment. And so it really is something to just help you grow and practice as a problem solver, but you don't have to turn it into me today, and you also don't have to finish the whole thing.